Everybody get a seat. Come on, we got to go. We don't have a lot of time, my friends. Welcome to this particular talk at this particular time. This is Reactive Revolution or Reactive Spring. I'm not sure what the abstract said, but let's assume it's one of those. We don't have a lot of time, and as a result, I encourage you, my friends, to take note of this one slide, okay? This one slide. Actually, while you're still, I'm going to wait until everybody comes on in. Come on. But while people are sitting down, you should be taking a photo of this one slide, this one particular slide. This has the most important information that you're going to see this hour. It has several bits of information that you should note. In fact, if you were going to take a photo of one slide, this would be that slide. You should take a photo of this one. This contains the code that you're going to be able to follow along with at your own leisure later on, and it contains the coordinates to reach me on the inner tubes. So how many of you have Twitter? I'm just curious. Twitter 2019. Twitter 2019. Okay, the rest of you, what are you doing? Get on Twitter. It's the new IRC. It's a great place to be. It's where the developers that drive the open source that power your business are. So you owe it to yourself to be there. What about email? What about email? How many of you are using email? Anybody? Does anybody use email? No, good. Moving on. I'm not really a big fan. Okay, come on, my friends. There's some seats in the front if you like. It's going to be a little weird sitting that close, I suspect, but you can do it. Oh, it's cropped. That's not great. Look at that. Oh, look at that. Okay. There, you can see the code now, sort of. Yeah? I'll move this down here. All right. No. Oh, my goodness. Come on. There you go. So you can, there you go. Can you see all that now? Just barely? Yeah, good. There you go. Take a photo of that one. Good stuff. Come on in. So while we're all here and we're about sat down, where everybody's basically in their seats, I want to take a selfie, okay? We're going to take a selfie, and I like to take selfies because I have a daughter, and she's 14. She's very smart. She's smarter than I am. And so whenever I go to these conferences, I like to take a selfie with the people in the audience, and I take the photo home to my dear daughter, and I say, see, they listen to me. Okay, you ready? Okay, ready, steady? Okay, just pretend like you're happy, okay? When I say open source, you say open source, okay? Open source. Yeah. Good stuff. All right, my friends, we don't have a lot of time, so as I say, let's sit down and get going. A little bit about me. My name is Josh Long. I'm a Spring developer advocate on the Spring team. I work on the open source projects. They made a toy out of me in China. That's kind of interesting. If you're in China, you can find me there. I have some videos on Safari. This is an all-you-can-eat technical marketplace for technical content. I have a book called Cloud Native Java that I wrote in 2017, all about how to build applications that survive and thrive in the cloud using Spring Boot and Spring Cloud and Cloud Foundry. I do a podcast every Friday called A Beautiful Podcast, and you can find that wherever you listen to podcasts. How many of you listen to podcasts? I'm just curious. Okay, good. Find me there. I expect to hear from you. That's good stuff. It's just every week. It's just me talking to somebody who's smarter than I am, and there's a lot of people out there, so you can imagine it's always kind of interesting. People in the ecosystem, right? Every Tuesday, This Week in Spring, it's just a blog, me looking at all the latest and greatest in the ecosystem. And of course, every Wednesday, a screencast called Spring Tips. And today, my friends, we're going to talk about the subject of my new book, which you can buy now, but it's not yet done. If you buy it now, you can read it now, but it's not finished. We're going to talk about reactive programming. Now, reactive programming is a fairly moderately new solution, not very new, of course, it's 10 years at least, a fairly new solution to a very old problem. A very old problem that has only been made worse in recent years, okay? This problem is, how do I scale? How do I handle more users? How do I handle more demand, more requests going into my services? And this is not, as I say, this is not a new problem at all. This is an old problem that has been made worse in recent years. It's been made worse for a lot of reasons, right? It's not hard to think of a few things that have exacerbated this problem. You've got things like IoT, right? The Internet of Things. You've got the move to client service-based applications thanks to the introduction of the iPhone and then the Android and tablets and smart TVs and Xboxes and Rokus and all these things that are now clients to your different services. We've got the move to microservices itself, right? So now, when if you think about how it used to be 10, 15 years ago, you'd go to your desktop browser, you'd open up a page, you'd load the HTML, maybe some CSS, and maybe some very little bit of JavaScript, and that was it. That's everything that was required to show that particular page. Well, now, any one view, any one screen that you see in a given client experience could in turn result in a whole cascade of other requests, right? You might have 10 or 20 requests that happen in the back end to other services, and they might in turn call other services. Who knows what your average view looks like today, right? Amazon talks about how many network calls are on their services. So now we have this huge problem where we're making more network requests. We're moving more data across the wire. Okay, so this is problematic. It means that we have to be able to handle that extra capacity, that extra demand. And the question is, how do we do that? And the other question is, why can't we already do that, right? What's the thing that's limiting us? And so that's what we're going to talk about. We're going to talk about reactive programming as a way to sort of address that, right? Now, of course, this problem is not new. Like I say, it's not new. The idea is very simple. What we want to do is we want to give our runtime some idea about how to better use its resources, right? Think about what happens when a network request comes in software written in yesteryear, 10 years ago, 15 years ago. Think about the traditional sort of approach to software that looks like that. You have a Java net socket that connects to a Java net server socket. And the server socket waits for the incoming request, and as soon as it accepts the incoming request, there's an input stream and output stream that are created, and there's interactions between these two things, right? You read and write from both sides, and you exchange data. And as you're waiting for the bytes, what's happening? You're sitting there. If you're a socket, you're sitting there waiting for the bytes to come across the wire, right? And as you're waiting, what's happening? Well, if you're using an input stream, you're just sitting on a thread, aren't you? We call that blocking. It means you're sitting on a thread. You're not able to reuse that thread for anything else. And that is the real problem. Input and output is not the actual problem. It's the fact that that traditional approach to input and output requires threads. And this is where we get into one problem, right? The other problem is that as we move to this new world where we have lots of different API requests, we are going to see that we have a lot more opportunities for failure. We have a lot more opportunities for issues that will happen that we don't necessarily anticipate when we think about working with regular input streams and output streams. These issues are not things that you think about normally, but they're far more likely to happen. So we need to rethink the way we deal with distributed systems, the way we think about moving messages from one node to another. Right? So there's two problems here. One is that it's expensive to scale up this one thread per request approach. And the other is that we need a better way to deal with streams of data, especially distributed streams of data. That's where reactive programming comes into play. Okay? Now, let's think about that first problem. The first problem is that threads are expensive. Right? They are. They take 1 megabyte of context per thread backed by the JVM. Right? It means that if you want to scale out, you have to create more threads. This becomes untenable. Right? You might have a good number of threads, but you're not going to have nearly as many threads as you have users, right? And besides that, think about it, right? Do you actually have the ability to create unlimited threads on the JVM? Let's assume you had unlimited RAM. Do you have the ability to create unlimited threads and do something interesting in a sort of unlimited way? Well, of course not, right? Beyond the number of cores on your machine, you don't actually have true concurrency, right? You have just the number of cores, and anything beyond that is scheduling. It's an illusion. You're moving work on and off CPUs in a fast way to make it look like you're doing things in concurrency. But that's not what's actually happening. So we need to be able to be a little bit more effective, a little more efficient with the way we handle those threads. So, what is the solution? Well, a very old idea. Cooperative multi-threading, right? A very simple idea, very old idea. It says, hey, I'm going to give the runtime a clue about when I'm not using this thread. I'm going to say, hey, I'm not using this right now. So you can do something else with it, right? Most of the way we work with threads today is to use a Java thread. We actually create a Java lang thread, and we get to pretend that we have the whole computer to ourselves. We're the only thread in the whole system. We have our own context, our own namespace. We have some isolation from everything else, and it makes it seem like it's just all ours. We can do whatever we want. We can sit there and just count sheep, right? But that's not the actual case, is it? And we're not being very friendly with the way we handle resources in this way. So this is the first thing. If we want to get around this, especially as it concerns input and output, right, we need to think about, what things can we do that block threads? Well, input and output is one thing, right? input and output based on Java I/O input stream and Java I/O output stream. That kind of input and output blocks threads. What else blocks threads? Things that are computationally inefficient, right? Things that are like that work on the CPU. Things like Fibonacci, right? Or cryptography, Bitcoin, Slack, right? These things take up all your CPU. Not good, not good, right? So the trick is to avoid doing these kinds of things in your code, if you can avoid it. Obviously you can't sometimes, and that's fair, but those are things that block threads. What can we get rid of? What in that whole list of things that we just talked about can we get rid of or at least mitigate? Well, input and output is an easy one. Input and output is an obvious one, right? We don't have to use traditional java.io.input stream and output stream. We can use java.nio, etc., right? Channels and so on, right? We can use that Java NIO to support asynchronous I/O. Asynchronous I/O gives us the ability to say, hey, I've asked for data, but it's not here right now. So in the meantime, here, somebody else use this thread. I'm not using it. Somebody else can use it. As soon as the data arrives, I'll be given a notification, a callback. And so then I have the opportunity to work with that data. It's an interrupt, okay? So what we need is some way to describe data. We need a data type that we can use to say, hey, this is data that's not here right now. It's not one record. It's not 0 records. It's not necessarily 10 or a billion records, but it's some number that's possibly greater than 0, and it's asynchronous. It's not here right now. So a future doesn't quite work the way we want it to work, right? A future is just one record. We need something that we can use to describe possibly many records. And this is where the Reactive Streams specification comes in. The Reactive Streams specification are a set of APIs that were developed by Pivotal, by Lightbend, by the Eclipse Foundation, by Netflix. These different organizations got together a few years ago, and we defined 4 very simple interfaces that allow you to extract out this idea of a reactive or latent and potentially asynchronous stream of data. Those types are very useful. And we're going to see those in just a minute. They're so useful, in fact, that they have since been incorporated into Java, in the JDK itself. Those types, as we will see, are very, very useful, but they're also very basic. They don't have support for operations like map and filter and flat map and so on. These kinds of operations are very important when dealing with streams of data, just like you expect to be able to have them when used with Java 8 streams, right? Same thing here. We need those kinds of operators. So Project Reactor from Pivotal, RxJava 2 from Netflix, etc. These projects build on top of these core types, and they give you the ability to work with these kinds of streams of data, to compose them, to operate on them. And they go a long way. Is that enough, though? Are we done? I would say no, of course not, right? What good are these types if the things that we use to build software don't support them? What good is the Reactive Streams types if it's not well integrated into the technologies that we use to deliver software into production? Imagine, just hypothetically, that for whatever reason, for some reason, the technologies with which we are familiar, the ones that we have used for a long time, imagine that they did not know about or care about Java util set or list. Imagine that whenever you tried to do a hibernate entity, just hypothetically, right? Just a hypothetical example. Imagine you tried to do a Java util set for a one-to-many relationship in Hibernate. Imagine that it didn't just hate it, right? It really does not like this at all, but it didn't just hate it. It didn't just throw an exception. Imagine that whenever you used a Java util set to map a one-to-many relationship in Hibernate, that it rendered an ASCII art middle finger. And then kernel panicked the machine. Would you continue to use Hibernate with Java util sets if you knew that you could expect this kind of abuse? Of course not, right? And by the way, I'm not suggesting that you give up Hibernate. If what you want to do is to map objects to JDBC data structures in a synchronous and blocking way, there's nothing better, right? Obviously, and you want to go to production, so you're not going to give up on that. You're going to use what allows you to get to production faster because you're good developers. You're good engineers. You'll use whatever the path of least resistance is. This is the same problem that we have with these reactive types. They're not useful if they don't help us at every layer, if they don't support things like data access, like web applications, like security, and so on. We need to have integration at every step of the way. So here's where Spring comes into play. Spring Framework 5.0 and later supports reactive programming. Spring Framework 5 came out in 2017 in September, so more than 2 years ago. We just released Spring Framework 5.2 and Spring Boot 2.2. So now we've got Spring Data, Spring Security, Spring Batch, Spring Integration, Spring Cloud, Spring Framework, all these different technologies now integrate reactive programming end to end. So today, my friends, we're going to explore all that. We're going to see how all these things come together to support building really, really interesting scalable systems, okay? And of course, to do that, my friends, in order to do that, we're going to go to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It is better than Disneyland. But if you have not been to production, you can begin your journey here at start.spring.io. If you need inspiration in the early morning before a cup of tea or coffee, start.spring.io. If your children are restless and they cannot sleep, start.spring.io. And if you suffer from indigestion, a sour stomach, after a long night of alcohol abuse and PHP, start.spring.io. So we're going to build a new application today, my friends. We're going to use Spring Boot 2.20, which was just released today, like right now, today, like a few hours ago. That's nice. We're going to use that. We're going to build a new service. It's going to be called Service. We're going to confront some of these options. We have a few options that people may not be familiar with. Let's revisit some of these. First of all, the first choice of that we have is of packaging. What kind of packaging should we use? People get confused by this. They don't know which kind of packaging to use and when and where to do it. Let me explain. Let me do my level-headed best to explain here now when and where to use which option. If by some terrible fluke of physics, some terrible tragedy of time-space, somehow you find yourself transported to the distant past, far beyond modern help, then choose .war. But if you're here with me in 2019, then choose .jar. This is a big part of my overarching, guiding personal philosophy of make jar, not war. Again, lots of things that you could do, but I encourage you to accept the defaults. Now, we also have to confront the choice of Java. What version of the JVM do we want to use in 2019? My friends, of these two options, only one is correct. Java 11 is the correct one. Java 8 is not the correct one. It's both Java 11 is the correct one technically, of course. It's faster, it's secure, it's the better JVM. And it's got long-term support. So Java 12 and 13 are also acceptable. They're also correct. But Java 11 is certainly correct, right? It's the technically more correct choice. But it's also the morally more correct choice. Are you prepared to go home and confront your children with the fact that you're still using Java 8? Are you ready for that conversation? I don't think you are. I don't think you are. So use Java 11. Do it for the children. Now, my friends, we're going to bring in the reactive web support. We're going to bring in Lombok. We're going to bring in R2DBC for database access. We're going to bring in MongoDB as well. We're going to bring in Postgres as well. And I think we have everything we need. Oh, we also want OurSocket, okay? So we've got a number of different technologies here. That's going to be used to generate a new project. And I'm going to open up this project in my IDE. And it doesn't really all that much matter what IDE you use. Anything will work just fine so long as it supports Java and Maven or Gradle, etc. Or if you're using Kotlin or Groovy, then you have to support that as well. So we're going to go ahead and launch this application. We're going to launch this code in IntelliJ. Anything works just fine. NetBeans works just fine. How many of you are using NetBeans? Good stuff. How many of you are using Eclipse? Right on. Good stuff. How many of you are using IntelliJ? Whoa, that is by far the majority. Good stuff. What about Emacs? Are you here, sir? Where is he? Every single, it doesn't seem to matter what city or country I go to. Every time I ask, who uses Emacs? It's the same guy. The same one. Every time I ask, he says, I do. And then he leaves, going to the next city to troll again. Anyway, I've got my application. Can you see that font? Oh, of course you can. It's the size of a building. So we're going to go ahead and close this, and I've got my application. Let's go ahead and comment out some of the stuff that we don't need just yet. So for now, I'm going to comment out R2BC. Good stuff. I'm going to comment out that. I think I'm happy with my selections. I'm going to hit Enable Auto Import. Good. Why isn't that the default? And then I'm going to now create an application that saves data into the database. So I'm going to create an entity that maps to an object of type reservation. So I'm going to have two fields. This is going to be using MongoDB. I've got MongoDB running on my local machine here. Okay, so that's a database here, MongoDB, and I'm going to say db.reservation. Okay. .drop. All right, there's everything. Now, I've got this essence. This is the entity that I want to describe. This is the thing I want to map to MongoDB. MongoDB is a document database, so each object will be mapped to a document. You have multiple documents inside of a collection. That collection is like a table. A document is like a row, okay? So I'm going to say @document, and that's the essence of what I want to express in my Java code. But this is Java. It's Java, so I need to do things like this, and this, and this. And that, and whoops, I need a constructor, don't I? And that, and that. Okay. Why JPA? Why? Okay. So this isn't JPA. You don't actually need this for Spring Data MongoDB, but just remember you do need it for JPA, which it's 2019, so I'm not sure why that's a thing. Anyway, there's my entity, and that's disgusting. It's just hideous. So instead of doing that, I use Lombok, of course. Lombok's a compile time annotation processor. You just add @data, and voila. Now you can either use Lombok or any other language. So either way, you'll get much less code, right? Any other language from the last 20 years on the JVM will support making this easier, right? Scala, Groovy, Kotlin, I mean anything, right? Anything at all. There you go. So now, there's my entity, and what I want to do is I want to write this to the database. I want to create a thing that's going to write data to the database. So I'll create a repository. Now, a repository is a thing that's, it handles the boring data management lifecycle. A repository is just an interface. I'm going to extend the interface, and it's going to provide methods like save all, find by ID, count, delete, etc. All those methods should be very obvious to you. What may be different are the names. You see, this is a publisher. This is one of those types from the Reactive Streams specification right here. It's a publisher. A publisher publishes data to a subscriber. A subscriber consumes the data. When the subscriber first subscribes to the publisher, it is given the subscription object. This subscription is arguably the most important thing. So we're going to come back to this in just a second. When we get new data, when the data is published asynchronously out of band to the subscriber, the onNext method is called. When there are errors, they are propagated not as a try-catch, kind of thrown exception thing, but they're propagated instead inside of the reactive stream as just another kind of data. This is a very functional way of thinking about the world. And this also makes sense because remember, reactive programming is all about moving work from one thread to another. Stack traces are limited to a thread. So it's much more useful to put them in this mechanism, right? And then we have the onComplete method, which gets called whenever you are done processing data, whenever there's no more data to process. Now, let's go back to this subscription thing. This represents the session, the link between the producer and the consumer. The subscription is what the subscriber uses to request more data or to stop the data. This is a very important but very simple concept. We are saying that the client, the subscriber, controls the rate of production. This is flow control, client-managed flow control, and it's not a new idea at all, of course. Ever since one computer has been on the same network as another computer in all of history, there was flow control. Somebody had to think about what happens when one computer goes faster than the other, right? Not a new idea at all. It's just that with this API, it's now a thing that we can deal with and explicitly control ourselves. That allows you to build more robust services. In the world of reactive programming, sometimes marketing becomes bigger than actual technology and actual ideas. So when you hear the word back pressure, that's just marketing for this basic idea that's been around forever, okay? Flow control. I control the rate of consumption. You cannot denial of service me if I am the one who's asking for more data. You don't, instead of having data pushed to me, I ask for the data and I get when I want it. and no more, okay? So we have the ability to control the rate of consumption. That's 3, right? That's publisher, subscriber, and subscription. I said there's a 4th one. It's called processor. And a processor is a thing that is a bridge. It's a subscriber and a publisher. And that's it. That's the entire Reactive Stream specification. If you understand that, you're already certified Reactive. Congratulations. Go to Silicon Valley, raise $1 million, throw stupid parties, come back a failure. You're ready. You're ready. You're already ahead of most people in Silicon Valley. Now, these are the basic types from the Reactive Stream specification, but as you can see, they're fairly boring. So we have 2 specializations that give us operators. The first is called a flux. A flux is a publisher, but this comes from Project Reactor. Okay, this is a pivotal project called Reactor, and Flux is a publisher that produces 0 to n values. It could be potentially unlimited, it could be 1, 2, 3, etc. We have a lot of different operators here though, okay? And then we have also mono. Now a mono is a publisher that produces at most 1 value, okay? They're both publishers. One produces unlimited values, one produces at most 1 value. Now if you understand these basic things, let's write some data to the database. So I'm gonna create a sample data initializer, like so, okay? It's gonna be an event listener, like so, public void, whoa, come on, void, ready. And when this application starts up, I'm going to listen for the application ready event, and I'm going to inject my reservation repository here. And of course, I can create a constructor myself, or I can use Lombok there. And what I want to do is I want to write some data to the database. So I'm going to create some names. These are people on the Spring team, all right? People on the Spring team that have, you know, a special place in my heart. So there we go. We've got Dr. Sire. We've got Olga. We've got... that's 4, right? Yeah. And we've got Spencer, we've got Violetta, we've got and we've got Yo, it's me. Okay, good. Now, we've got some names. Okay, there we are. There's our names. Let's write these out. So names.map, each name, I'm going to turn each one into a reservation. That's a reservation. It's a publisher. It's a stream of reservations, okay? Now I want to write these to the database. I'm going to say reservations.map, and I could do .map, and what happens if I do that? If I call .save on this, if I just pass in this like that, that turns into a method reference. What happens if I do that? Well, map takes this lambda that I've given it, and it takes the return value, and it collects the return values into another publisher. So you get this monstrosity. You get a publisher of reservation. We don't want that. So instead, you got to flat map it, right? Flat map it unpacks the intermediate type like this. Now, if I ran this code right now, what do you think would happen? Nothing. Yeah, I heard somebody say nothing. So you have to subscribe. Right now, this is a cold stream, right? Nothing happens until you subscribe. But if I ran this multiple times, if I restart this program multiple times, it'll write the same data to the database. So before I run this code, let's first of all clean it up. And then second of all, let's make sure that we also clean up the database. Let's reset the database so that there's only, there's no data in the database. And then we write the data. So I'm going to say delete all. And then let's write the data to the database. And then let's find all the data, and then we're going to finally subscribe to the results like so. And I can provide a consumer or a subscriber, and here I'm just going to create a little logger, and I'm going to log out the results. Okay, log.info reservation. Good stuff. Okay, there we are. Good stuff. Okay, now this could be a method reference. Good stuff. Now let's run this. Let's run it. There we go. Oh. Did you hear that? Oh, you're welcome. You know you're jealous. Don't lie. All right, look at that, huh? Look at that. There we are. There's the names. It worked. Of course it worked. It was a demo. It was a demo. That was always going to work. There was no question. That's not what I wanted to talk to you about. What I wanted to talk to you about is this. This is the Spring Boot ASCII artwork. We on the Spring team have many people who are doctors, PhDs, people who in their previous lives worked in nuclear physics. So it makes me very happy to imagine that someday, somewhere, somehow, there was a GitHub issue. And I think you can agree they did a great job. So it's for this reason that I want to take a brief moment, a very brief moment to talk about what I consider to be a very serious, glaring deficiency in the IntelliJ JetBrains product. Because even though I'm a big fan, I consider this to be particularly short-sighted. Do you see this checkbox right here? This one. This one right here. Do you see that? Do you see this checkbox? This one? This one. That one. Do you see it? If I were to click it, don't click it. if I were to click it, it would suppress the output of the ASCII artwork. It would actually remove the artwork. What the hell? Why is that there? Nobody even asked for that feature. That's a dumb feature. So I did what all people would do. I went on the internet and I cried. And I was given a message of hope from my friend Jan Sebron. This is Jan Sebron right here. He's a developer advocate at JetBrains. This is him right here. This is my friend Jan. Boop. Anyway, he sent me this message, which I want to share with you today. A message of hope. Anyway, you know, I've known him for a long time, and I want to believe him when he says that. I've known him for a long time. Every time I ask him, he says, "Don't worry, Josh. It'll be fixed in the next release. Just relax, Josh." And you know what? I want to believe that because I'm a friend. He's my friend. I've known him for years, but I'm starting to think that just maybe, just maybe he's lying to me. I don't know. Whatever. Moving on. We've got data in the database. We've got amazing ASCII artwork. Now I want to build. I'm using MongoDB right now. Now MongoDB is fine. There are several different reactive data access options for Spring users. There's Spring Data MongoDB, Spring Data Cassandra, Spring Data Couchbase, and Spring Data Redis. This is not the same as all of Spring Data. There's also Spring Data Neo4j. So we've got 5 NoSQL reactive driver implementations. But there are many more Spring Data projects besides those 4, or there's 5 now, right? That's because we have to build these implementations from the ground up. We can't take an existing blocking data access technology and build a reactive implementation on top of that. So we have to have a reactive driver, an asynchronous IO-centric driver to make this work. And this is also true for SQL. This is a big problem. People have asked us for so long, how do we do SQL-based data access in the reactive world? And if you're using JDBC, there's not really a good answer, right? Because it's a blocking API. So we have a new project that we've created along with a number of people in the community called R2DBC. R2DBC has a core SPI, and there are a number of different implementations out there. So we're going to go ahead and comment out MongoDB, and I've got R2DBC now in the class path. I'm going to keep the R2DBC Postgres implementation. I don't need the JDBC one, thank you. And with that, I can change my code a little bit here. Obviously, this is a very simple example, so it works. But most of the time, of course, you can't take your SQL data domain and make it work with MongoDB or vice versa. But I can do that here because it's trivial. And the only thing that really needs to change is I need to change the primary key from a string to a monotonically incrementing integer, right? And that's it. That's my. Oh, I also need to provide a connection string. So I'm going to say R2DBC. URL equals R2DBC Postgres localhost orders, okay? And we need a username, don't tell anybody about this, orders. And we need a password, orders, okay? Now, let's run this code and see what we get. Let's run it. All right, now I've got a Postgres instance here, P SQL, uorders, orders, D, okay? Select all from reservation. There we go. Okay, so 645, 639, 642, etc. Okay, 645, 639, 642, etc. So now we're doing reactive SQL data access, and there are a number of different implementations out there already. There's PostgreSQL, MySQL, H2, Microsoft SQL Server, Google Cloud Spanner, I think is working on one. So a lot of good ones out there. Now, I have data in the database. I want to build a simple HTTP endpoint. I want to do reactive HTTP. And I can use @REST controller. If you know about Spring, you know about @REST controller. But I much prefer the functional reactive style. So I'm going to say route like this. Good. And good. And there we are. /reservations, new handler function, server response.ok.body. And what I'm going to do is I'm going to provide the reservation repository. I'll say rr.findall.class. So it's a reactive stream of type reservation. That's why I have to specify that type token, that second parameter there. So there's my functional reactive HTTP endpoint. Look how simple that is. It's a predicate on the left, and then there's a lambda on the right, or a method reference if you want. Okay. So now I can go here, localhost reservations, and there we are. Not a big deal, right? There's our 8 records. Now, that's a terrible use of reactive programming, isn't it? I've done SQL and JSON. You could do this yesterday, right? You didn't need Reactive for that, right? I did 8 records of JSON, not even that impressive. So the question is, where does this really come into its own? Well, reactive programming comes into its own when you have large amounts of data. It comes into its own when you are trying to conduct a large amount of data, or potentially you need liveliness, right? So things like stock tickers and chat messages and presence notifications, these kinds of things are good uses for reactive programming, because if you didn't have reactive programming, how would you implement that? You'd keep a thread open, wouldn't you? You keep a thread, and then you'd keep a client and a socket, and you'd be communicating with each other all the time. You'd never disconnect. In order to do that, you'd have to keep that thread open. So this is where reactive programming really comes into its own, where it becomes very useful. So let's now instead create a very simple service that'll do greetings, okay? Greetings service, okay? And this greetings service is going to produce a greetings response for every greetings request that comes in. It's going to produce a never-ending stream, an infinite stream of responses given a request, okay? So here's this. And the response will have a message that we're going to produce. And the request will have the name that we should greet, the person that we should greet. So this will be a service object, and this is going to be a DTO. It's going to have our basic annotations here, okay? Good stuff. So there's our basic thing. Now we're going to create an infinite stream. So using the Java 8 Streams API, we're going to produce a new supplier. We're going to say a new greetings response. Hello, r.getName at instant.now. Like that, okay? Now that's going to be producing an infinite stream of data. Now an infinite stream of data is nice, but it's going to be so fast we won't be able to see it as it scrolls off the screen, right? So what we want to do is to slow it down a little bit. I'll use a timer here. I'll introduce a little bit of a delay by saying delay elements. And the reason I can do this is because there is a scheduler. The scheduler is what moves work from one thread to another. That's what makes reactive programming so interesting. There's a scheduler involved in everything. You don't have to worry about it usually, if you don't want to, but it's always there. I could have told this thing here, I could have said that this pipeline is going to execute on a particular scheduler, a particular thread pool. I could have done that if I wanted to, but you should not need to do that. By default, every program has one scheduler with one thread per core. Each thread is an event loop, and as long as you don't block, everything will be fine. Now the question, of course, is what happens if you do block? Well, you're going to cause memory contention. And so we created a Java agent. You're going to cause thread contention, rather. We created a Java agent called block count. You can use this. It's just a very simple project that, Wi-Fi is a little slow here. It's a little Java agent. You just say block count.install. Oh, well, whatever. Come on. It's a Java agent. You just say block count.install there. And when there's any kind of blocking work on a thread, on a reactive non-blocking thread, you'll get an error. It makes it very easy for you to find any issues where you're blocking the thread where you should not, okay? So you should not need to override the scheduler, but if you need to, now you know how. So we've got this scheduler. Let's create a thing that uses it. I'm going to create a WebSocket endpoint, okay? So I'm going to create a little WebSocket endpoint here that'll actually take our service and create a WebSocket feed. So WebSocket handler, okay, and WebSocket handler adapter. Okay, and here's our simple URL handler mapping. So this, think about the way WebSockets works, right? WebSockets are a binary protocol, and the binary protocol requires clients to connect to the HTTP service, and then there's an upgrade. There's a handshake, and then they upgrade to the binary protocol. So you start with HTTP, and then you upgrade to the WebSocket protocol. In order for that to work, we need to map our WebSocket handler. This is the bean that we've described up here. That's this. We're going to come back to that in a second. We're going to map that endpoint to a HTTP URL. That's what I'm doing here. I'm establishing that mapping, okay? Now, this is where we're going to do the actual business logic in the greetings WebSocket handler, right? So GS, okay? Now think about what happens. When a WebSocket client connects to the application, a brand new WebSocket session is established. And we're going to use the session to receive the incoming requests. And what are the requests going to be? It's going to be a name, isn't it? It's going to be a single name that we can turn into a greetings request and then send into the greetings service. So we're going to take each name like this. We're going to map the name to a string, okay? There you go. There's the names. Now, it's a publisher. It could be infinite, but you and I both know it'll only be one. And I'm going to take each one of those names and turn it into a new greetings request, like that. Okay, so now I've got a stream of greetings requests. And then for each one of those, I want to map the greetings request object and call greetings service.greet, passing in that. Now, of course, I shouldn't use map. I should use flat map, right? Because I'll get a stream of streams otherwise. So there's my responses. Now for each response, I want to take the response and get the message, the string message from the response that we created, right? So there's the string flux. And now I want to take each one of those and map it into a WebSocket text message like this, okay? So there's my WebSocket text message, and I want to send the whole thing to the client like that. Now that's my entire flow, that's my entire pipeline. And I've written it long form for you to see what's happening, but I wouldn't write it like this. I would not anymore, right? I'm very comfortable these days just saying chain it together because I know what's happening, right? So you collapse it into one little pipeline and send that whole thing back, okay? There's my whole thing. And of course, this could become a lambda. There we go. So there's my entire receive. Good. Now, I want to demonstrate this to you. And in order to demonstrate it to you, I need to do something terrible. Something that I would not do if I could help it. If I could think of a more polite way to do this, if I could do something more expedient, I would. But I don't see any way around this. And I apologize, okay? I need to do something that I would not do in polite company. I need to write JavaScript. So, static, ws.html, HTML, script. Okay, and all I'm going to do in my JavaScript program is I'm going to say window.add-event-listener load function, function, okay, var ws equals new WebSocket, ws localhost 8080/ws greetings, okay, ws.add-event-listener open, so when the socket first connects, there's going to be an on-open event. When there are new messages, there's going to be an on-message event, and what I'm going to do is I'm going to send a name using the WebSocket. I'll send a name saying GeeCON Prague, okay, and when the data comes back, I'll log it out. So e.data. Okay, let's restart this. Okay, localhost. There we go. See that, my friends? That is an infinite stream of greetings. It's going to produce a new value every second for the rest of time. As long as there is heat in the universe and this computer is plugged in, this will keep going, right? And that's not as bad as it sounds, because in between the raindrops, we're not going to block that thread. Somebody else can reuse it, right? This is going to go on and on and on and on and on, forever and ever and ever. It has no end. It is endless. It is infinite. It is without fin. It's like the oceans and the skies and the stars and the bugs in your code, just infinite. Infinite, my friends. And that's okay. That's okay. So this is a good example of where reactive programming really comes into its own. Each individual transaction is not faster. It might even be a little tiny bit slower. Very small, but still, because you have context switching. But we can handle a lot more transactions now, right? That's the benefit of reactive programming. And we also have a superior way to deal with streams of data. We have back pressure. It gives us the ability to say to this thing that might be failing, hey, we don't want to worry about this anymore. We're going to try something else. So let's do one more thing. We've got this WebSocket endpoint and this greeting service. I like that service. WebSockets are a nice, it's a nice protocol. It's a binary protocol. How do you do security with WebSockets? I don't know. I'm asking. As far as I know, there's no good way to do it, right? You can create a stomp message and then pass along a token inside the stomp header, but that means you have a payload inside of your stomp message, inside of your WebSocket message, which is a little silly. There's no headers in WebSockets, right? What about multiplexing? How do I do that with HTTP, for example, if I wanted to do REST? There's no good way to do that, right? You can do pipelining, but that's like halfway there, right? You're going to lose out on some speed opportunities there. It's very inefficient. What about back pressure? What about session resumption and canceling? All these things are not really well supported by HTTP. They're not well supported by WebSockets. There's a lot of things where if you kind of examine it over the large sort of swath of time, it looks like HTTP and WebSockets are great protocols for building document retrieval systems. But they don't seem like great protocols for building high-speed reactive services. And so there's a new protocol called OurSocket. OurSocket was a protocol developed by Facebook. It's a protocol, actually by people at Netflix and at Facebook. And this protocol has a lot of really interesting qualities to it, not the least of which is that it's natively reactive on the wire. The protocol has information in the wire about how to communicate back pressure to other services. It's also payload agnostic, so it doesn't care if you send binary data or text data or whatever. It's stateful connection, so you connect once and you have a long-lived connection. One of the reasons that HTTP is so slow for microservices is because you have to constantly connect and disconnect, right? This stays connected. You don't have that constant reconnect and hacking time. It has headers, so you can do things like sending reactive streams of data with tokens in band, right, in the body of the message. There's just a lot of nice things about it. So Spring supports OurSocket, right? We've integrated it into Spring Framework 5.2. That's what I'm using here. So let me go ahead and quickly create an OurSocket service. I'll do this and this. There we go. That's done, okay? Now, I'm going to create an OurSocket server port. I'm going to say run on port 7777. And I'm going to create a new client, going back to start.spring.io. Okay, close that. And we're just going to create a new client here very quick using just OurSocket. And Reactive Web, might as well. Okay. And Lombok. So we're going to hit generate. Downloads. RMRF client. Yeah, okay. Whew, makes my heart stop a little bit. Okay, you never know. You never know what you're going to delete. So let's see. All we want to do in this very simple thing is going to act as a client to our OurSocket service. Okay, easy enough. Now we go here. We're going to start up a new service on port 9999. And we're going to create a OurSocket client. So OurSocket requester is what it's called. Because remember, in the OurSocket world, there's no such thing as client service. Once you're connected, either side can initiate the discussion. Either side can send a message. It's not like a client service architecture. It's more a peer-to-peer architecture. So there's my OurSocket requester. And then what I want to do is I want to create a component that just writes or that listens for the, or that makes a request rather, and writes it out. Okay. So public static class listener. Okay, private final OurSocket requester R. Okay, and okay, and this is just going to be a bean application ready event public void go. So I'm going to say go to it's going to already be connected, right? It's already connected to port localhost 7777. Go to that endpoint called greetings. Send the following data, which is a new greetings request. And we're gonna do something terrible, something that you should never ever do ever. Not even when you're all by yourself at home and no one is looking. Okay? We're gonna do something terrible. We're gonna copy and paste code. So I'm gonna copy and paste that code here. So we have the DTOs for the wire communication. I'm gonna send a new greetings request. GeeCON Prague from OurSocket. Okay, and we're going to send the data. We're going to expect a greetings response stream back. And then for each record that comes back, we're going to log out the results like this. Good. Let's start this program now. There we go, my friends. Every second, in perpetuity, forever, we have a new greeting. Over the wire, it's a binary protocol. We're not blocking. We can do true session resumption. We can do fire and forget. We can do bidirectional push. We have headers. We can do reactive streams that go on forever. We don't need WebSockets. We don't need HTTP. It's a very nice protocol, and it's natively reactive. My friends, we're just about out of time. I had fun. Who had fun? Awesome. I am so grateful for you all. Thanks for coming. I hope you learned something here. I hope you liked what you saw. Who liked what you saw? Just curious. Good stuff. I know that I like it. Obviously, I like it. I'm wearing the Spring t-shirt. I'm a big fan. I'm wearing the Spring underwear. Obviously, big fan. Big fan. But I'm not the only person out there who's using this stuff to great effect. There's lots of interesting organizations out there that are doing amazing things on top of the stack. Alibaba is a small company in China. You might have heard of them. They're going to be big one day, and they're all Spring. Everything is Spring. Nowadays, there's also a lot of Spring Boot and Spring Cloud, and now, even more recently, OurSocket. I'm touring different cities in China later this year to talk to local communities about OurSocket and Spring, right, with Alibaba. That's one thing. Netflix, of course, right? They're all in on Spring Boot and Spring Cloud, and also some of them are using OurSocket as well. They're using Reactive Programming as well, right? Lots of different organizations out there building amazing stuff with these technologies because they know that allows them to build better software faster, to deliver more stable services into production where their customers can use it, and they can do that faster. And at the end of the day, my friends, that is all that matters. Thank you so much, everybody. Thank you so much.